Hey, moving on, in Module 15, we'll be talking about lenses. Our vocabulary, we'll be covering the converging lens, focal points, diverging lenses, convex shapes, and concave shapes. So, a useful fact is that rays can bend when they travel through transparent objects. This has been shown with the experiments we've done so far in the text. So here's a lens and here's a ray that is entering the lens, and it enters at a line perpendicular to the surface at the point of contact. So the line comes in at this point and it actually enters perpendicular to the shape there at the surface. A ray strikes the transparent object and it's refracted. The light will bend towards a line perpendicular to the surface at the point of contact. So once that line comes in, it gets refracted or it gets bent by the material or substance that's in the lens. A light ray will travel through the glass along the path indicated in the illustration we just showed. At some point, the ray will reach the edge of the glass object and it's going to exit. At that point, the substance the ray was traveling through changes, so it changes from being inside of the lens now to being in the air. Consequently, the ray will be refracted again. Because light travels faster in air than in glass, it is bent away from the perpendicular. So now, our original light ray that entered the lens now hits the other side of the lens and is refracted again. It's also refracted perpendicular to the point of contact, and you can see that it has refracted twice. The first time when it hit the lens, the second time when it exited the lens. So light rays can also travel horizontally toward an object. They would get a result similar to this illustration. So we have a lens, but if we have several horizontal rays that hit basically at a 90-degree angle here to the lens, they will be focused to a single point. So check out each light ray. You can see that it enters the lens. When it goes to exit the lens, it actually bends toward one focal point. So it's a single point. This is the focal point, and this type of lens that will do this is called a converging lens. So it actually converges the light rays into this one focal point. Now you can see after that focal point that the rays actually move off in a different direction. Just as an illustration, this lens is drawn very wide, but actually it would be very thin. So think of something as thin as the contact on your eye. I'm sorry, I'm having a little trouble with my slides here. They're all over the place. Unlike converging lenses, diverging lenses change the situation. So we went from this shape that you can see right here to this shape. And when the light hits this lens, refraction causes a completely different result than with the converging lens that we just studied. This is called a diverging lens or diverging lens, and light is bent outward, causing the rays to move away from each other. So you can see that the light rays enter horizontally, but because of the shape of the lens, they're separated and moved outward. You can see that the sides of this lens are curved inward. The previous lens, the sides were curved outward. So this type of lens, the diverging lens, is called a concave shape. It actually caves in. The other type of lens, the converging lens, will have a convex shape. Lenses actually work because of their shapes. So when you go to get eyeglasses or contacts for your eyes, they actually measure the shape of your eye to fit the contact on there so it can make a correction to the shape of the eye to make your eyesight better. The lens shape or curvature is not the only thing that affects the way that a lens works. Thickness can also affect the way a lens works, but the amount of curvature also plays a role in the result. So if you have just a slight curve, light will bend one way, but if you have a very deep curve, it will separate on a diverging lens and spread further outward. So hopefully this helps. We'll be moving on to our last video in this series in 15F. Go on and do your own problems, and we'll talk again soon.